In this video, I am going to show you how you can install Phixtral locally on your Ubuntu system. You can use the same commands for in any collab. I will also share the commands which I am going to use in this demo. So don't worry about copy pasting them. I will put the link in video's description. Okay, now back to Phixtral. Phixtral is one of its kind model. Phixtral is the first mixture of expert made with 4 Microsoft Phi 2 models. It has been inspired by the Mistral's 8 into 7 billion architecture. It performs better than each individual expert. Now in this video, I'll be using the quantized version from blog. So let's get started. Let me go to my Ubuntu system. And for Ubuntu, I'm going to use my Ubuntu 22.04. Let me quickly show you the version of Ubuntu I'm going to use. I'm going to use Ubuntu 22.04. Let me clear my screen. The first step we need to do is to install some of the prerequisites. Now, I'm going to install transformers, INOPS, accelerate, and few other things. So let me do it. And I already have installed pip and Python on this Ubuntu system. So these are done. Now let me fire up my Python interpreter where I'm going to show you how to install and run this Phixtral LLM. Now one thing, I am using one GPU on this Ubuntu machine, so make sure that you have GPU configured, otherwise this won't work. The first step is that we need to import some of the libraries. First I'm importing PyTorch. PyTorch is an open source machine learning library developed by Facebook's AI Research Lab. It's widely used for various applications in AI including NLP, computer vision and neural networks. Secondly, I'm going to import the auto model for causal LM and auto tokenizer like this. Now, just to give you a quick idea, auto model for causal LM is used for autoregressive models like GPT models. A model is autoregressive if it predicts future values based on past values. Whereas auto tokenizer is a generic tokenizer class that will be instantiated as one of the base tokenizer. Now let's specify our Phixtral's model name. Let me quickly do that. So here I am specifying my Phixtral model, and now let's also give me a prompt. I'm just going to ask it which one came first, egg or chicken, and you can have your own prompt if you like. So I'm just going to go with this one. Okay, prompt is set, and now let me set my prompt template which is specific to this model. And here I'm using im_start for system and im_start for user. Im_start is a token, a special token that represents the beginning of an input message. So im stands for input message here. Okay, so that's done. And now let's set the default device to CUDA with the PyTorch library. Now this command sets the default device for tensor operations to a CUDA enabled GPU. And tensors are the fundamental data structure similar to arrays in other programming language, but they are optimized for fast computations. And CUDA stands for Compute Unified Device Architecture. CUDA is a parallel computing platform and API model created by NVIDIA. By specifying CUDA as a device, this command is telling PyTorch to perform tensor operations on the GPU rather than the CPU. Okay, now that's done. Now in the next command, I am using auto model for causal LM to download the model. So this is a command I'm going to use. Now in this one, this command is used to load a pre-trained model for a causal language modeling task. And as I mentioned earlier, auto model for causal LM is a class in the Hugging Face transformer library. The auto prefix suggests that the library will automatically infer the specific model architecture like GPT-2, 3 or whatever based on the name of model provided. In our case, it will be Phixtral. And when we say from pre-trained, it means that this is a method used to load a pre-trained model. In our case, Phixtral. So it is basically enabling us to initialize a model with weights that have been trained on a specific task. And in our case, because we are using autocausal, the task will be causal language modeling or autoregressive. Let's run it. And also we have this torch D type. Torch D type specifies a data type for the PyTorch tensor, and we have set it to auto. It means that the model is automatically going to choose the appropriate data type based on the pre-trained model and the capabilities of our hardware. And then we have load in 4-bit. So this is a quantization, and this parameter is used for model quantization, as I mentioned, and it's a process to reduce the precision of model's weights. And loading the model in 4-bit mode means that the weights are quantized to reduce memory consumption, potentially at the cost of slight reduction in precision. So that is already done, which is good. And now let's initialize our tokenizer with auto tokenizer. Auto tokenizer is a class in Hugging Face transformer library. It automatically detects and loads the appropriate tokenizer for the given pre-trained model. So for this, it is going to automatically select the tokenizer for our Phixtral model. Okay, so that's done. And now let's tokenize our input prompt with this tokenizer. And so this is a prompt which we have specified above in the prompt template here in this one. And then we are also setting the return tensor is equal to PT. This return tensor is equal to PT tells the tokenizer to format the output as PyTorch tensors. In this context, PT stands for PyTorch. This is very important because the output needs to match the type of tensor expected by the model you are using. If you are using TensorFlow, then we will use TF. Okay, that is done. And now our tokenizer initialize. In the next step, we are going to generate the output with the help of this input and max length 200. Max length 200 specifies a maximum length of text sequence to be generated. So in this case, the model will generate text up to 200 tokens in length. This is a way to control the length of output so that the model doesn't provide excessively long sequence. Let's wait for the model to come back. It is processing our input at the moment. And depending on your bandwidth, it might take a bit of a time. Let's wait. That's done. The model has generated the text and it has stored it in output, but it is still in the numeric format. So let's use the bash decode function to decode that output into proper text. That is done. And let's print out the text, which will be our answer of our prompt where we were asking which came first, egg or chicken. There you go. So model response is that the egg came first, the chicken is an animal that lays eggs. And then it is reasoning about it and then giving us the answer. And then it is again just initiating the dialogue among user and system. And of course, we have just trimmed it down to 200. That is why it broke it here. Otherwise, you could print a lot of other information. So this is it, guys. You can see that we have installed and we have ran this Phixtral model so easily on our local Linux system. And as I mentioned earlier, you can use the same commands on Colab or any other Linux instance locally. I will also put all the commands which I have used in my blog and put the link in video's description so that you can follow along. If you are stuck having issues, let me know and I'll be very happy to help. And if you like the content, please consider subscribing to the channel. And if you are already subscribed, please share the channel among your network as it helps. Thanks for watching.